Hey everybody, I'm Sari and this is Sari on Science for Arizona Science Center. I know a couple of you are just joining us. We're back by popular demand. We were upstairs doing a Facebook Live and got so many requests to do more student interviews, we had to come back for you. So here we are. I'm going to ramble this on just a little bit to let more people join us, but we are off-site from Arizona Science Center today. We are in Pittsburgh, Pennsylvania at the Intel International Science and Engineering Fair, where we have more than 1,800 finalists from more than 81 countries, regions, and territories all over the world. And of course, we have our amazing Arizona finalists here competing against them. They're some of the best and brightest young scientists I've ever met. And look behind me, you can see the span of projects we have, this long hall filled with projects. If you didn't get a chance to see us when we were in the hall upstairs, this one's even bigger with more projects. They're just filled with cutting edge original research. So I'm in amazing presence right here with these guys. I have great company. Hi, say hi everybody.
Hi.
Hi. These are some of our Arizona finalists, and we're going to start over here with Daniel. I know, it's a little informal. Say hi to the world.
Hi.
Hi world. So Daniel, we're actually standing in front of your project. So step right up here. So first off, Daniel, what high school did you go to?
Brophy College Preparatory.
So you're at Brophy, right in Phoenix. So an Arizona native?
No, I was born actually in Pennsylvania, but I moved when I was young.
Okay, so you're like coming home.
Yeah.
Excellent. So it's fun either way for you to compete. You're still on like home territory.
Yeah.
Beautiful. Well, can you tell the world a little bit about the research that you did and the work that got you all the way to this international competition?
Yeah, sure. So for my project, what I did was I created a computational radiation shield that under testing was able to prove to be 99% effective in blocking incident particle rays. In addition, my model was over 14,000% cheaper and over 7 times thinner than one of the leading shields created by the European Space Agency. So that was basically my whole project.
That sounds really intense. How would your work be applied in real life? What are they doing with this type of shield?
I believe that this type of shield can be used in a variety of applications, from space to prevent rays from entering, for example, in space probes. Additionally, it can be used in healthcare or even in agriculture or even in nuclear plants to help people who are working inside.
How would it help them?
It could, for example, in space, it could prevent cosmic radiation from exposing to people within, for example, spaceships and space probes. Additionally, it could be used in healthcare, for example, in screening for better and more effective screening with the use of higher power rays. It could also be used in agriculture and for the general public and safety because right now there's a lot of growth in nuclear energy and nuclear weaponry, so it's important that we stay safe on Earth as well.
That's amazing. So would you say this is pretty important as we talk about the future of space travel too?
Definitely, especially in our efforts towards Mars and other planets. It's definitely important that we keep in track of the increase in radiation in space and how we can block radiation from exposing to us in our pursuits in space travel.
Excellent, because we're going to be spending a lot more time in space in the future, right?
Yeah, definitely.
Absolutely. So I'm leaning on you to make sure that I stay safe when I get my trip to Mars.
Okay.
Plan. So we're going to check in with our folks on Facebook. Hopefully they've had a chance to join us live. Do we have any questions, Tara? Tara from the back. Awesome. No questions yet, which is all right by here. So thank you. We're going to jump over here to, we've got a couple other guys. We've got one more of our projects over here, so come on over. We've got 4 of our finalists, 2 of our projects, but we've got Sukesh. Hi, Sukesh.
Hi.
Tell the world hi, and then talk about your project and what original research you did to get all the way here to this international competition.
Yeah, so I utilized Rutherford backscattering spectrometry, combining nuclear resonance and channeling to study the native oxides grow on silicon and gallium arsenide semiconductor surfaces when you leave them out in the atmosphere.
All right, so using semiconductors, and for those people at home who don't know what applications semiconductors have, can you talk a little about that and why they would care that you even did this research?
Yeah, so a couple of things. First off, a lot of device manufacturers who make things like smartwatches and phones and tablets, they're looking at ways in which they can cut costs and maximize efficiencies. And native oxides have been empirically proven to create high costs and minimize efficiency. And so if we can even put out numbers there, like if we can simply put numbers out there on thicknesses of native oxides, we could save billions of dollars for people in the industry.
One more time, because you're not the first person to use this word today, but did you say billions with a B?
Billions with a B.
Billions with a B.
B.
So your work could potentially save us billions of dollars in the industry.
Definitely, because so many devices use semiconductor chips. For example,
Like what? Yeah. For example.
like I said, phones, smartwatches, tablets, practically anything that can think.
Yeah, okay.
And then the other application of my research could really be in revolutionizing the solar cell industry. So right now, there's a lot of ways into looking into merging different types of semiconductors. And so my research actually can be applied to a process known as nanobonding, whereby the process of wet chemical etching, which I was specifically examining, can change the hydroaffinities of various semiconductors. And so if we can quantify how much you're changing the hydroaffinity, that could absolutely make the process of merging these semiconductors a lot easier. And it could help us move towards a more carbonless future, especially in a world where solar cells are extremely expensive. It can make it more competitive, and I think it could really make a difference.
So you're saying not only could we save more money, but we could have more clean energy and make that clean energy cleaner.
Yeah.
Oh my gosh.
And have cheaper phones.
And have cheaper phones. So that's your takeaway from this. The work that Sukesh is doing could give you a cheaper phone and cheaper solar panels. Amazing work. Great job, by the way. Good luck on the awards. I know we have special awards tonight. We'll be learning how our students did. And we've got 2 more students with us over here. Oh, and remind me, what high school do you go to?
Basis Peoria.
Basis Peoria. So another Arizona amazing young scientist. So we've also got Brian and Joseph over here. So come on over, Joseph. You can join us here. We're standing away from your projects in the hall, but we want to hear a little bit about what you all studied. And Brian, since you're closest to me here, we'll start with you. What did you study?
So I basically worked on optimizing and maximizing the efficiency of a process that's integral to many AI applications, and thereby lowering the computational burden of many of these AI programs, so that those extra resources could be used for much more effective applications and more learning.
Okay, so AI being artificial intelligence.
Sure.
So more efficient means what?
So it's basically like a trade-off between like the resources that you have and what you want to do. And so I basically focused on one of the most inefficient tasks that AI applications have to work on, regardless of whatever they want to do. I lowered the efficiency, or I increased the efficiency, 20 to 80% with comparison to the fastest way to actually do the process, and therefore I saved up so many more resources that, depending on the program, can be used for everything from training self-driving cars to be more efficient to actually like working on computer vision and robotics. It all depends on the program, but I worked on the general base level of programs that everything has to use.
So people have been hearing about AI, artificial intelligence, a lot lately, and you mentioned driverless cars. Can you maybe mention other places in someone's everyday life where they might see artificial intelligence and maybe don't know?
Sure, even on the most basic level, like Alexa and Google Assistant, the voice assistants that you have to deal with, they're constantly learning from you, and they're constantly like adding new data points to their entire to their learning structure. And so if you can find a way for them to interact with and understand from those data structures even more, you can actually create more realistic data assistants. You can create more like smarter homes, everything just gets smarter.
So we just recently saw Google release their new Google Assistant's been all over the news, sounding like a real person with the ums and ahs and pause points that sound so realistic. So would the work that you're doing, does it impact that train of thought and all of that industry?
Sure, because when you look at it, it's the Google Duplex, which is like the AI assistant that does that. It's sort of using like high-level computation and running off of supercomputers to basically like create the actual realistic voice characteristics. So by reducing that computational burden, you can actually make the assistant even more lifelike, and you can actually make it even more effective to deal with everyday solutions that it might not be able to deal with right now.
Amazing. Well, great work, by the way, and you are all blowing my mind with the work that you're doing. So remind me what high school you're at?
Brophy.
Brophy. Another Brophy. Awesome. So then we're going to jump over to Joseph and have Joseph talk about the work that you did, which was not in math, but in?
My project is in computational biology, right? So essentially what I'm working on here is I'm essentially looking at how the 3D folding of DNA in the cell nucleus changes over time, right?
Wow.
So the reason that this is important, while it might not seem immediately intuitive, is because actually we've discovered recently that this has a big impact on gene expression, right? But our current models of how this folding actually influences gene expression have not been really successful in explaining all of the phenomena we observe in our in vitro studies. So I essentially created a new method to actually find dynamic and spatial interactions in DNA, and this enabled me to essentially find a lot of new insights into what actually happens in the genome, especially during events like genetic diseases like cancer, and also learning a lot more about the actual relationship between structure and function in the genome.
Wow, and in very simple terms, because again, so impressive, great work. Why would someone at home care about the work that you're doing today?
So I think that one of the more exciting things that I found is that actually all cancer cells share common structural disruptions. I am actually the first person to discover that a common characteristic of cancer is actually deletion in certain regulatory structures in DNA, and so this could lead us to understand the disease better.
So if we can find where the deletions are and know what those deletions are going to be.
Yeah, exactly. We could potentially fix the deletions to maybe revert cancer, but also at the same time, a problem with cancer is we don't understand it very well, right? Because we don't understand the genome very well, and in cancer we often see different things, like we see mutations, right? We see disruption in a process called epigenetics, but we also, I'm now adding a new dimension to it because we actually also see disruption in the spatial holding of DNA, right? So that's a new as I said, a new dimension to this kind of study.
Amazing.
Field. Yeah.
Wow. Well, I know that a lot of people have loved ones that they care about so much and are trying to figure out how to cure this disease. So many of us have been affected by it. So great job on all your original work. We appreciate it. So we're going to step back here. Oh, and remind what schooling. You are homeschooled, if I remember correct.
Yeah, I'm homeschooled.
Amazing.
Yeah.
Well, great work. And we've got all of our finalists right back this way. Hi. Oh, and we're joined by two more. Excellent. Nikita, just in time. All right, so jump over here really quickly. I'm going to put you on the spot. Nicely done. And in your one sentence, can you tell the world a little bit about your research that you did?
Yeah, so in my research, I developed a new approach for improving algae biofuel production by creating a process that helps harvesting algae by clumping it, and it's also much cheaper, environmentally friendly, and much better overall.
Much better in what way?
So current techniques we use right now are not very efficient because they cost a lot, they require a high energy input, and they don't recover a large amount of the raw material you need for producing fuel. So mine goes away from all of that by making it much more cheaper, time efficient, and environmentally friendly.
Amazing. So we've got environmentally friendly biofuel, and we had another conversation about making clean fuel even cleaner to produce. So it sounds like you're on the boat in that direction as well. Algae fuel, right in Arizona. Mm-hmm. Is there a lot of algae in Arizona?
There are quite a bit of algae farms and algae companies. So doing this project was really, those things really inspired me to do this project. So,
Excellent. And then worldwide, we've got worldwide application for biofuels.
Mm-hmm. So in a lot of third world countries, agriculture is the main leading source for jobs. So by going towards using more algae biofuels, more algal farms would be created, and then opening up jobs in many third world countries around, and even here in the U.S.
Amazing. So Nikita, you're not only trying to give us clean energy, but you're also saving us money and making more jobs.
Yep.
In high school. Amazing. Remind me what high school you're at.
I go to Basha High School in Chandler, Arizona.
Basha High School.
Yeah.
Great job. All right, finalists, come back here for just a second. We're gonna bring all of our finalists back over here because we want to ask a general question for you all. Now, again, for anybody just joining us, we've been going over the projects from our amazing Arizona finalists here at the Intel International Science and Engineering Fair in Pittsburgh. 1,800 contestants from 81 different countries, regions, and territories. So Arizona students, you've had a chance to get to know or meet people from all over the world, and this is a once-in-a-lifetime experience. Can you talk a little bit about anything you've been experiencing this week, or that's exciting, or that you're still looking forward to? And just feel free to shout it out. We don't have to go down the line.
I mean, I've just had a great time meeting people from all sorts of cultures and backgrounds, and getting to know what kind of science that they've gotten involved with. It's really inspirational. I don't get to meet these kinds of people anywhere else. So
amazing.
Just the way of thinking that different cultures have. I'm entered in the math category, and just the way I've seen people from different countries deal with traditional math problems is completely different from the way I've been taught, and so that's sort of interesting to view.
What I thought was really interesting is that despite everyone being from different countries and everything, being separated by a long distance, that we all have the same motivations and stuff, and that we all have the same ideas, and we all want to present ourselves well.
Yeah, so I'm going to kind of piggyback on that. So, because there was a lot of people, it's a very diverse community. A lot of people from different countries. They brought their problems and they did their research on that. So I kind of got their perspective on their culture, maybe problems that are going on in their country, and what they did to solve it.
Amazing. So I'm so excited. You guys are just, you inspire me every single day. I'm so excited for the future. So thank you for joining us today. Thank you for being here, for all the work that you've done all year long and to get to this competition. Really, really great work. So you heard it here, folks, for everything from the future of space travel to cleaner energy to new ways for artificial intelligence to be installed in your home. We're talking about more efficient science all the way around and so much more. We'll keep you posted on how our amazing students are doing here. Please look for more information here on Facebook and on Twitter. You can find more information at azscience.org, and we'll see you next time with Sari on Science. Bye, everybody. Bye.